Welcome back to the series Programming in Python, and this is session 3, where we'll talk about functions. Remember, in the past two sessions, we talked about introduction to Python, flow of control, and in this session, we will talk about function, and the rest of the topics we will see in further videos. What are functions? Functions are named group of instructions to accomplish a specific goal. For this to happen, after the definition of functions, the function needs to be called to run in a particular program. It helps to achieve reusability and modularity. What do you mean by reusability? Once defined, a function can be called any number of times, any place in the program. For example, if I have to add two numbers, I write instructions to add two numbers, given two numbers. And if there is a need for adding two different numbers, I have to do the statements all over again. A function helps to reduce this work and define a function to add with parameters being passed on demand. That's the beauty of reusability. When it comes to modularity, it's the ability of a function to operate independently and as part of a larger functional unit. As I mentioned earlier, a function can be called any number of times and at any place after being defined. That's the key aspect. Without defining a function, if you try to call a function, it will result in a syntax error, undefined function. A function can also be called from within another function. A function call within a function is also possible. And a function is created with the definition statement def. We'll look at some examples for functions, basic functions. Function with two arguments. I'm defining a function for adding two numbers. Def add underscore numbers, number 1, number 2. And the sum is number 1 plus number 2. And I'm printing the sum with the text sum is, or sum, the number, the resultant number. Now, I've just defined the function. Until it's called, it's not going to do anything. And there are two things with respect to function that we need to remember. One is parameter, another is argument. We'll talk about that later. But here we talk about arguments. So I'm calling the function add numbers with the two numbers, number 1 being 5, number 2 being 4. Here, when I defined the function, I did not give the values. I just gave representative variables, which will be passed when the function is called. That's the arguments we talked about earlier. In the case of parameter, the value itself will be assigned or retrieved, received from the user within the function. We'll see an example for that in a bit later. So now the output for this particular function is 9. Now if I have to do another addition, for example, add 10 and 20 or any two numbers, I don't have to write or declare number 1, number 2, add again and print again. All I have to do is call the add underscore numbers function with the two parameters and just execute it. I'll get the result accordingly. The next example is something similar. I'm going to find a square of a given number with an argument. Define find square of a number, assign the result to the variable result number multiplied by number, return the result and call the function, assign the result of the function to a different variable. In the first example, we saw the value being assigned to a variable and the print happening within the function itself. Here, in my function, I'm going to just return the result and the result value will be assigned to a variable and that will be printed. It's a different way of defining and executing a function. So I'm assigning the result to a variable called square and I'm printing square. So if I call the function with find square of 3, I'm going to get an output. See, remember there is another way to get it, result equal to number square. This is another way of getting the square value for a given number. Let's look at the benefits of using a function. First is reusable code, as we quickly discussed earlier. The same function can be used many times within the program, which results in reduced size of actual statements. The number of lines get reduced. Eventually, the size of the program is also optimized. We don't have to repeat the statements over and over. New functions can be built based on already defined functions. That's another aspect of the reusability feature. And code readability. When the program is defined with function usage, definition of functions and usage of function, the program is better organized. And if we have right set of comments, the program is easily readable and understandable. Anybody who's going to use or maintain it. And debugging of errors get much easier. If we just keep writing and we don't have function calls, and if you have every activity or operation written by individual statements over and over repeatedly, and if there are issues, it's very difficult to find out where the issue started and where it resulted in. But definitely defining functions and calling them with appropriate values where required, it's very easy to figure out which function call failed or created a problem, and it's easy to fix. Next topic is user defined function. When we say user defined function, this is basically defined by the programmer to complete a specific task. So does that mean we have ready-made functions or functions given by Python system? Yes, there are many built-in functions. We will look at some of them. This is the basic syntax for a function definition. We saw a couple of examples following the similar pattern. Define with the keyword def, function name, and parameters 1, 2, 3, and so on. The function need not have a parameter also or an argument also. That's also a possibility. And parameters can be any number as well. The def statement, the def function name should end with a colon at the end, and the set of instructions with the proper indentation. Instructions to be executed or what we want to do with this function, all those things are given. And if there is a return value, yes, return the values, one or more, or just print and come out. So that's the syntax, basic syntax. Parameter 1, 2, etc. are the parameters and are optional, as I mentioned earlier. And function may or may not return a value. The function name should be unique and follow the rules of naming conventions. Remember when in the introduction session we talked about how to name a variable or a function or an identifier, right? It should start with an alphabet followed by an alphanumeric or an underscore, and it cannot have some of the special characters. So that rules should be followed in the function naming as well, and indentations should be followed very strictly. Otherwise, we'll have confusion. We saw some example in the previous one. We'll see some other examples also in this session why indentation is very important. Let's look at some of the important points to remember when we are dealing with functions. Parameter is accepted within the function itself. The values of a parameter are accepted within the function itself. Here is an example for parameters. I'm adding two numbers and I'm going to get the values for those numbers within the function definition itself. First number, input, enter first number. Until the user gives the first number, nothing happens. Similarly, second number, user has to enter the second number, and the sum is first number plus second number, and print the sum of first number and second number is the resultant value. So when we call the function add num, all these things are happening are defined. Anything that should happen is defined within the function. So the input for first number, input for second number are given by the user, that is captured within the function. The addition happens within the function, and the print to the output device is also done within the function. So all we have to do is just call the function. Argument is passed to the function at the time of calling. The values for arguments are passed at the time of calling. Here is an example for argument usage. I'm defining a function to add all the natural numbers up to a given number by the user. So I'm defining sum squares of n. N is the parameter here. Sum equal to 0. I'm starting with the 0 value. For I in range from 1 to n plus 1. Remember the syntax for range function. Range, start, stop, and step values. Here the start is 1, stop values n plus 1, and there is no step given. And the output or the range function creates an output out of list until the given stop value minus 1. So if you want to get a series of numbers till n, we have to give n plus 1. That's what is given here. So the sum is sum plus I. Sum is instantiated as 0. So when the range starts with 1, the first value will be 1. And until it goes on until the n value. So in this case, I'm calling the function sum squares of num This num value is entered by the user as per the program here. But remember, if I don't have any input, I can call it in a different way, like sum of squares within bracket, the actual number itself, say 10, 20, and so on. Here in this case, I'm retrieving the value or receiving the value from the user's entry. Strings can also be parameters for a function. A default parameter can be set during function definition, used when there is no argument at function call. For example, when we have a function defined for adding two numbers, I can have number 1, number 2 equal to 5. Number 1, I'm just leaving it just as a parameter, and number 2, I'm setting a default value of 5 to number 2, which means if I don't give any value for number 2 while calling the function, it will always refill that value with 5. In the list of parameters, when we set a default value for a particular parameter, all the parameters following that parameter should also have defaults. Say I have 5 different parameters in a function and I'm setting a default value for parameter 3. It's a rule in Python that parameter 4 and 5 should also be set with default values. A function argument can be an expression as well. The argument is calculated first before the function is run. This is another feature. You can give an expression as an argument, but expression is calculated first. For example, 4a plus 5 with the value a. So 4a plus 5 is calculated first, and then the function is called. This is passed as an argument value for the function. The most important pointer, function is not executed until it is called somewhere in the function, and before a function is called for the first time, the function should be defined. These two should be kept in mind. Next is variable scope. What is exactly a variable's scope? Scope is nothing but a variable scope is nothing but the part of the program where the variable can be utilized or referenced. In other words, the life of a particular variable. We have two different types of variables. One is global variable and the other is local variable. Global variables are defined outside a function or a block of code. These global variables can be accessed by any function in the program after the global variable is defined. Until the global variable is defined, the usage is not possible by any function, but once defined, it can be accessed by any function. And any change to this global variable will affect function accessing the global variable naturally, right? I define a variable which I can pass for any function down the line, but if there is a change, it's going to impact every function that is going to use the variable. The next is the local variable. It's defined within a function or a code block, and it can be accessed only within the function or block where defined. Once defined within the function, its scope does not go beyond that function. It can be only accessed or referenced within that function alone, and it exists only till the function is. As we saw earlier, a function can be called multiple times within a program. So when I call each time, this local variable gets instantiated, used, and then once the function call closes, the variable also is closed. It doesn't have any uh, possible references outside this function. Next, we will see Python standard library. Python standard library is a collection of built-in functions readily available to use, which can save time. And also available are groups of function called modules. Function is a group of statements. Module is a group of function. Modules enable use of functions created within one program across other programs if saved under a module. For example, I write 10 and save them as a module. And these 10 functions can be used across as long as they are part of a module. This is a typical function types within Python. We have standard library and user-defined functions. Under standard library, you have built-in functions and modules, that is a collection of functions. Built-in functions. These are readily available functions. Most commonly used functions are made into a collection. Related functions typically. And modules are group of functions stored as one module, and it should be imported before usage. That's the difference. When I create a set of functions into a module, and if I want to use the module that is a collection of functions, into another program or somewhere else, I have to import the module first and then start using those functions as part of the program. To call a specific function within the module, I don't want the entire module, I just want one function of a module. I can use this particular syntax, module name dot function name, to import and then use that function or call that function. Here are some sample built-in functions. There is a huge list, but I'm just sharing few of them. First set is mathematical, sum of, minimum, maximum, absolute of a number, power, square root, and so on. The next is data type conversion functions. Remember, we saw some sample statements to convert one data type into another, but Python offers built-in functions to do a lot of conversions. We have two input output functions in Python. One is the input to receive input from the user, and the print statement to send the output to a standard device. And there are some miscellaneous functions: length, range, type, import, and so on. We'll see few modules and some of the functions within those modules. First are the math functions, math module, factorial, fmod, power, square root, and stealing, and so on. Next is the random module. Random is helpful in creating random numbers, random choices, samples, and so on. Random is the module. And we have statistics module. Mean, median, mode, standard deviation, and so on are the functions within statistics module. There are so many other modules, and Python keeps coming up with new modules now and then that are, help with advanced programming or solving complex real world problems. Let's look at some of the module related tips that you can remember while creating functions and grouping them into a module. Module can be imported anywhere in a program. When you create functions and group them into a module, and we want to use them in other programs, the import can happen anywhere in the program. It need not be at the start of the program, but it must be imported only once. Even if you import multiple times, the other imports will be ignored. The first import alone will be considered. Functions within a module can be called after the import naturally, right? When if you have a function within a module, and if you're not imported the module, the functions within the module cannot be called upon. If you want to see the list of modules, use help of modules. It will show all the modules present in Python. And if you want to see the list of functions within a module, type help the module name, so you'll see all the functions listed within the module. A from statement is used to import a specific function instead of an entire module. Remember, as I mentioned earlier, that a particular function of a module can alone be imported and used within instead of importing the entire module. A from statement helps you do that. The syntax is from the module name, import the function. The sample given is from random, import random. Here, both module and function names are random here. Similarly, any function as part of a module, you say from the module name, import the function name. I'll show you some sample programs on the IDLE related to functions before we can recap, and I can give you some sample programs to work on to practice functions. Since the programs are little large and they have multiple statements, I have stored them into Python files. We'll see one by one. In the first sample, we are going to calculate the cost of a tent that has a cylindrical part, a conical top, with a tax being applied. We have GST, right? So a tax being applied. First function defines the area of the cylinder, def COL, height, radius as attributes here. So area of cylinder equal to the formula for cylindrical part area, and returns the area in square meters. The second function is area for the conical part. Similarly, a function definition with two attributes and a calculation of area assigning to area of the conical part and returning the conical part area. And the next function calculates the post-tax price, that is the net price which is being returned from the function. Now, I have to call the function and get the value of the area, cylindrical, conical, and taxation values, right? So for the first cylindrical part, the user is prompted to enter the height and radius, and the function cyl is called with those parameters, and the return value is assigned to CSA underscore cylinder as the area. The next is enter the slant height of the conical area in meters, the conical part. So again, the conical part's area is also calculated and assigned to CSA conical. Now, calculate area of the canvas used for making the tent. So we have the cylindrical part and the conical part to make up the tent, right? So add up the area of the cylindrical part and the conical part to come to the complete total area. So the area of canvas is canvas area meter square. Now to calculate the canvas cost, we need to know the price of each square meter of the canvas. So unit price is prompted from the user. Once the unit price is entered, the total cost is calculated as unit price multiplied by the canvas area. But we have to apply the tax. So the total cost of canvas before tax is the total cost that is calculated, and the net amount payable is with the addition of tax that is calculated from the post tax price function with total cost as the input parameter. Now let me run this and show you the results. The user is prompted for values for cylindrical part, that is height. I'll give the height of 10 meters, radius of 6 meters, slant height I want say 15 meters. Area of canvas is calculated as 659.4 square meters, and it's asking for the cost of canvas for each square meter. I say 1000 rupees. So the total cost of canvas before tax is so much, and the net I will pay with taxes so much. I'll show you the next sample, a simple one to add two numbers. Remember, we saw the add num function as a sample in the presentation. First number, second number, both are prompted for the user to enter. The function calculates the sum, prints the sum within, and all you have to do is call that function add num. Enter the first number, enter the second number, and the sum. One thing we have to remember here, as we saw as part of function definition, you have a def statement and the function name starting with an alphabet and a colon to define the function. If either of these, the def being wrong or the function name starting with a number or the colon missing or a different symbol being present, the interpreter is going to show an error. This is the next sample we saw as part of the presentation. The sum of natural number up to a number n, with n being entered by the user. So same program I've given here for execution and see the results, how it works. It's asking for the number till the point where I want to sum. So let me say 25. The total of numbers 1 to 25 is 325. This is a good candidate actually for uh, showing the importance of the indentation. For example, I have a print statement here. If I print here, I mean, this means the print is part of the for loop. Since the indentation is with the sum, this print loop is considered part of the for loop. And let's see what happens. See what's happening. Since it's part of the loop, the print is being done every time there is a sum being executed. for each I within the for loop or within that range, both the sum and print are being executed. But this case, once the for loop is complete, the final number is getting printed. Let me take it back outside here. This means the print is outside the function itself, the definition sum squares itself. Let's see what happens. It shows an error because the print statement has the variable n and sum which are not available yet. I have not called the function yet, because of which the value for sum and the value for n both are not available. So it clearly shows why it is very important to have proper indentation in Python programming. We'll see another example for a string function. Here we are defining a function to get user's first name and last name from the user, and call the function to concatenate these two to print first name and last name as one single name. So definition, full name, first and last as arguments, and we are getting the inputs from users with the input statements. Let's see how it works out. First and last name concatenated into full name. Let's recap. Functions are used to achieve modularity and reusability. Remember, functions are set of statements, Python statements, grouped together to perform a particular task, right? So they are used to achieve modularity and reusability. The function is executed only when it is called, and before it is being called, the definition should be done first. Users can define functions with parameters or arguments. A function can return one or more values or none. Multiple values are returned with a tuple. The part of the program where a variable is accessible or referenced is called the scope of the variable. There are many built-in functions in Python as part of Python standard library. Module is a collection of functions. Remember, function is a collection of statements. Module is a collection of functions that can be used after an import. An import can be done, it can be done multiple times, but the first import alone takes control. The rest of the imports are ignored. To import a specific function of a module, a from statement should be used. From module name, import function name. I would like you to try out some programs to understand functions better. This will be very helpful in terms of understanding what functions are, how better we can implement them, what are the different ways functions can be defined and used, and so on. These are just simple ones you can try out. We'll go for complex programs using functions along with other modules uh, in the upcoming sessions. First one, create a function with varying length of arguments. Remember, we can have multiple parameters or multiple arguments in a function. So how do we create one with a varying length? Meaning, I define a function with say 5 parameters or arguments, and when I call, I can use only 3 or 4. How does it work? Here is a hint: to create functions that take n number of positional arguments, use star args as a parameter. Prefix a parameter name with an asterisk. Using this, any number of arguments can be passed to a function. Internally, all these values are represented in the form of tuple. Try it out and post your comments. Return multiple values from a function. Create a function within a function for addition with below conditions. The outer function will accept 2 parameters. Inner function will be called to add these parameters, and after these parameters are added, the outer function will add 25 to the sum of the parameters. Remember, the inner function adds 2 numbers, and the outer function adds 25 to the result and then returns. Create a recursive function to calculate sum of numbers with the highest number being entered by the user. Receive the highest number from the user and create a recursive function to calculate sum of numbers, meaning first and second number and the result plus third number, result fourth number, keep printing. Create a list of even numbers with the highest number entered by the user. Find the largest number given the list. Try both ways below. Compare each value in the list with the others and find the largest, and use a single find function to get the largest number. You understand, right? Keep comparing numbers in the list one by one with the others, and use a single function to get the largest number. Write a function that accepts a string and counts the number of upper and lowercase letters. Get a string from the user and check the number of lowercase letters, get the number of uppercase letters, and print individually. Happy learning.